Alright, in this worksheet, we're going to talk about basic set notations. This corresponds to book page 319. The first two main concepts of this course are sets and logic. Sets are used to categorize a group of objects or people with certain properties and how these different groups relate and interact. For example, consider a group of students who took Math 15, like this class, and a group of students who took Stat 50, right? They both satisfy math requirement for many majors. That's why probably you're taking this class. Are there students who took both Math 15 and Stat 50? Is it necessary that you take both? Can you just take one and not take the other one? So if you look at the group of people who took one, group of people who took the other one, maybe there are people who took both of them, maybe there are people who didn't take any of them, right? So what we're trying to do is you're trying to categorize people into different groups. These groups are called sets, and we want to see how these things interact. Speaking of majors, have you filled out your comprehensive student education plan, CSEP? I'm sure most of you guys have it already, but if you haven't, it maps out the classes that you need to take according to your educational goal, your major, the school you want to transfer to. Also, you want to review all your requirements for your major and possible school you want to transfer to. If you haven't done so, please visit this website. I'll link it in the video also, and get started on your CSEP as soon as possible. And also, you might want to talk to a counselor if you haven't seen one yet. All right, so let's look at the frequently used terminologies first. A set, so this is the title of our worksheet, is a collection of distinct objects or people or things, right? And those things are called elements. So basically, set is like a group, and elements are like individual members of the group. So another example might be like our class. I can think of it as a set. So set is our class. Set is like Math 15 class. And elements are individual students like you. So all of you guys combined will form a set, and you are an element of the set, which is our class. A set is usually named by a capital letter, a capital letter A, capital letter B, capital letter C, so on and so forth. It can be described in two different ways, by describing the property of the elements enclosed by a curly bracket, or by literally listing the elements enclosed by a curly bracket. So for example, our class. First way I can describe is students who are taking Math 15 with Mr. Cho. That'll be the first way of describing our set. Second way is literally writing out all 30 names. I think I have 30 students. All 30 names with the curly bracket. That'll be just another way to describe our class. Okay, let's look at part B. X with the symbol that's epsilon. A means the X is an element of a set A. Notice that I use A, capital letter A, to describe the name of the set, and element, I use a small letter X. So I can say X is a particular element, or X is a particular member of A. So let's say I name my class M for math. So basically your name, you, is a member of this class, M. Part C, a set with no element is called the empty set, Basically a class that has nobody in it, and denoted by either just curly bracket with nothing in it, or empty set notation 0 with a little slash. So this is a set that has nobody in it. So if I had a class but I didn't have any student, it's kind of like I don't really have a class, but there's like a class in name but nobody's in it. We can also compare two sets. If one set A is part of another set B, then we can say A is a subset of B is denoted by this symbol like this. It's like U basically sideways. So I can write it like that, or I can also write it like B, A. For example, I can say people who are in my class with glasses, who's wearing glasses, right? So I can say that group or that set is a subset of the set M, which is the whole class. Interesting fact about the empty set is a subset of every set, which is kind of weird, but that's what it is. Here I'm going to have you pause and work on number 2 and number 3. Actually, let me just go over one question on number 3. Let's look at number 3, part A. Circle that makes the statement true. Look at the set on the left here. It has 2, 6, and 9. Look at the set on the right, 2, 4, 6, 8, 9. I want to see if the set on the left is a part of the set on the right. It seems 2 is here, okay. 6 is here, but 9 is here, but 9 is not on the bigger set. So the set on the left is not part of the set on the right because 9 doesn't belong to the set in the right. So here I'm gonna nothing. You can also say this. Here I'm not gonna circle anything because nothing will make true statement. You can kind of do this if you're saying one is not a subset of the other one. I can say this and I can slash, right? So this means this is not a subset of the other one. Okay, so I'm gonna have you finish number 2 and number 3. We'll meet back at number 4. All right, let's look at number 4. Another set we're gonna consider is the opposite set. Consider a set of students who are taking Math 15, so that's M. How about the students who are not taking Math 15? They're kind of like the opposite. Either you take Math 15, you're taking Math 15, or you're not taking Math 15. They're kind of like opposite of each other. We have a special name for this opposite set. So the complement. So in mathematical language, the opposite is called complement. The complement of a set A contains the element that is not in the set A. The complement is denoted by A with the little dash thingy or A with C. So sometimes you see me write it as A with the little dash, A or C for complement. Another set that has a special name is called the universal set. Sometimes it's called universe set. I think I want to call it universal set. Like universe, it contains everything, right? So universal set is the set contains all the elements. I'm gonna underline all the element that we're interested in. So from the previous example, people who are not taking, so our set was people who are taking Math 15. So complement of that set is people who are not taking Math 15. So we have to kind of think about, okay, are we talking about people from PCC who are not taking Math 15? Or are we including everyone in California? Are we including everyone in the world? Like people from Alaska or whatever, back in Korea or Mexico, whatever. So sometimes we have to kind of define like what do you mean people who are not in it, like out of PCC or out of the world or out of the US. So that's going to be our universal set. Sometimes it's explicitly stated, sometimes it's kind of implied. So when I talk about students who are not taking Math 15, I feel like it's kind of limited to like out of PCC, right? That kind of makes more sense. So that's called the universal set. All right, let's see, number 6. I'm going to do a few problems number 6 and have you finish the rest of number 6 and number 7. All right, number 6. Suppose that the universal set U is 1, 2, 3, 20. Notice that there's ... This is like a lazy way of saying it goes on for, not forever, it goes on. So obviously this one I always try to say is 1, 2, 3, 4, 5, 6 all the way to 20. So instead of writing everything out, I'm going to say it's number 1 through 20, all the whole numbers. So sometimes you see this ... means if there's a clear pattern, then you can do that. Let's say, so that's my universal set. Let A be the set of even numbers. Write the set A, okay? So even numbers. Again, like, you know how there are 2 different ways to describe the set? So the question is like, it's a description of the set, and they want you to like list all the elements. So this would be like a second method. So even numbers 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. I needed more space. And set B, the set of numbers that are larger than 15. Okay, so this is B. Again, like 16 and on, but like including 100 or 1000, here our universal set is 1 through 20. So like out of those, the numbers are larger than 15. So it says larger than 15, so 15 is not included. So I'll start from 16, 17, 18, 19, and 20. So that's my set B. Okay, part C says write out the set B complement. Just notice the little C. Okay, so B complement, again, our definition of the complement was whatever is not in B out of the universe. So 1 through 20, whatever is not in 16, 17, 18, 19, 20 is 1 through 15. So here, that's what I'm going to do. 1, 2, 3, dot, 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 15. And describing words, the property of B complements. So these are numbers that are smaller than 16, right? All right, have you tried to figure out D? Let's see, let's look at E. Create a set S so that S is a subset of A. So I want to create an S so that it's a subset of A. So it has to be from A. So I'll just pick some random numbers. I'll do 2, 10, and 14, something like this, right? So I can say S is a subset of A because all the elements in S is also in A. They're like a subgroup of A. Because 2 is in A, 10 is in A, 14 is in A. So I can say this is it. Side note. If I had 2, 10, 14, and 7, they'll not be a subset of A because there's 7 there and 7 is not in A, right? Because of 7, it's going to be not a subset of A. Okay, and have you pause and finish the rest of the worksheet, and I think that's it for this worksheet.